In the vast silence of space, even the smallest change can rewrite everything we think we know. For months, the interstellar object 3I, ATLAS was a quiet mystery, a faint smudge of light from another star system, drifting passively. Then, 2 nights ago, it woke up. Something happened that sent shock waves through every major observatory on Earth. 3I, ATLAS suddenly brightened, not gradually but explosively. In just 6 minutes, its luminosity jumped by a factor of 4. A flash so fast and precise that amateur telescopes across continents caught it at the exact same moment. Mars orbiters burned fuel to reposition. The Deep Space Network abandoned ongoing missions. The International Astronomical Union called an emergency session, the first in years. Scientists who once shared data freely suddenly went silent. Whatever was happening out there wasn't just another cometary outburst. It was something no one could explain, and it was happening right now. It began quietly, as all revolutions do. In a small town in Germany, amateur astronomer Maria Schultz was running routine photometry on 3I, Atlas through her 12-inch telescope. Her software, set to track gradual changes, flagged an impossible anomaly: a sudden, vertical leap in brightness. The light curve wasn't a curve at all. It was a flat line, a vertical wall of light 1.4 magnitudes higher, and then a new, sustained flat line. At first, she assumed it was a glitch, a sensor flare, a software bug. But when she checked her calibration stars, her equipment, and even atmospheric data, everything was perfect. Within 30 minutes, her discovery was echoed. Observers in New Zealand, Arizona, and Brazil began posting identical results. The light curve was impossible. By comparison, the legendary outburst of Comet 17P, Holmes in 2007, one of the most violent on record, took nearly 2 days to brighten by a similar magnitude. What Schultz saw happened in less than 1% of that time. By midnight, the hashtag Atlas anomaly was trending worldwide. The global astronomy community was awake, staring at the same question: what could possibly cause such a clean, instantaneous burst of light? A chain reaction swept across the globe. Forums and Discord servers filled with overlapping screenshots and exposure logs, all matching down to the minute. Citizen science had fired the starting gun. Then, the professionals took over. The reaction was not one of caution, it was one of urgency, bordering on panic. The Deep Space Network, our lifeline to probes across the solar system, interrupted routine Mars telemetry. Its 70-meter dishes stopped listening to Perseverance and Voyager to capture radar reflections from a single interstellar visitor. The decision cost 22 hours of irreplaceable mission time, a move reserved only for life-threatening asteroid flybys. The global coordination escalated. By the following morning, the Very Large Telescope in Chile, Gemini North and Hawaii, and even China's Fast Radio Telescope had all dropped their planned targets. The International Astronomical Union voted 8-2 for a planetary-scale observing campaign. For 48 hours, humanity's finest instruments watched the same object. And then, silence. The same astronomers who had been posting hourly updates on social media suddenly disappeared. Private research chats went quiet. No new data appeared on preprint servers. No press statements, no leaks, nothing. Astronomy runs on open collaboration. This was a digital lockdown. Analysts tracking social media reported a 70% drop in communication from verified astronomers. Something had changed behind closed doors. A few automated logs, leaked from an anonymous insider at the IAU, painted an eerie picture. They revealed what the professionals saw in those 48 hours: non-gravitational acceleration 4 times stronger than any cometary outgassing could explain. An infrared plateau 30 Kelvin hotter than it should be, suggesting a massive, internal heat source. Faint, repeating bursts of gamma radiation at the object's exact coordinates. The data made no sense. And so, they said nothing at all. This is what they saw. This is what triggered the silence. Using differential imaging, the James Webb Space Telescope, diverted from its deep field mission, noticed something else. A secondary object. It was smaller, colder, and perfectly aligned with 3I Atlas's trajectory. At first, they thought it was a fragment, a piece of debris from the outburst. But it wasn't. Over successive scans, the secondary body maintained a fixed, unwavering distance of 120 kilometers. It wasn't drifting, it was orbiting. This discovery sent shock waves through the IAU's emergency channel. A natural object with a companion that close, moving at that velocity, would be gravitationally unstable. Tidal forces should have shredded a loose companion or sent it flying into a different orbit. Yet this pair moved flawlessly, locked together as if bound by an invisible, rigid structure. Even more baffling was the companion's spectral signature. It reflected almost no sunlight, but it emitted faint microwave radiation. This wasn't a reflection, it was active heat dissipation. It was dumping waste heat from an internal process. It had a power source. By now, most astronomers had stopped using the term comet. The official designation changed quietly from 3I Atlas C 2025 R2 to 3I ATLAS complex. The word complex was no mistake. It was a silent admission that this was not a rock. It was a system. Everything came to a head when the 3I ATLAS complex reached nodal alignment, the precise moment its orbital plane intersected Earth's. At that instant, every telescope, radio dish, and orbital observatory trained on it registered a surge. The gamma bursts returned. The infrared plateau spiked. The companion brightened and the region surrounding both objects filled with a faint halo of internal luminescence. The object was unfolding, releasing energy from within. And then the impossible happened. For the first time, 3I ATLAS emitted a directed radio beam. It was focused, narrow, and aimed precisely at Earth's ecliptic coordinates. The signal was brief, only 12 seconds long. But it wasn't noise. It carried structure, patterns, and harmonic symmetry far beyond any natural process. Within minutes, the transmission stopped. The light dimmed. The pulse vanished. The complex went silent once more, leaving one haunting question echoing across every observatory. Who was listening on the other side? For days, the world waited for an explanation. Then, one team broke the silence, the Square Kilometre Array, SKA, in Australia. They had reconstructed the full 12-second waveform. The beam wasn't random. It contained a harmonic structure built around the 21-centimeter hydrogen line, the cosmic water cooler, the universal frequency every civilization capable of science would understand. But the real shock came when the data was translated. The waveform, when converted into a spectrogram, revealed a repeating geometric pattern, 6 perfect hexagons spiraling outward around a central point. It was a blueprint. A mirror image of the James Webb Telescope's final images of the 3I ATLAS complex itself, with its companion locked in formation. The transmission wasn't just a signal, it was a schematic. Here is what I am. Then came the final, chilling realization. Project Helios, an internal task force, concluded the directed beam wasn't a first contact. It was a response. It had been transmitted just moments after the Deep Space Network and China's Fast Telescope had bombarded the object with their most powerful radar pings, trying to get a better look. We had shouted into the dark, and 3 IATLAS had illuminated us back. And it wasn't just a signal. It was an interaction. Precisely 12 seconds after the beam's arrival, Earth's own magnetic field, the Schumann resonance, the planet's heartbeat, fluctuated by 0.02 Hz. For a fleeting moment, 3 IATLAS had reached across 300 million kilometers of space and touched our planet. Now, the interstellar traveler drifts beyond Mars. Silent and watchful. The data is classified. The world has moved on. But among the astronomers who first saw the anomaly, one question remains. What happens when that frequency returns? What if the next signal isn't light, but something else? Because maybe 3 IATLAS never came to visit. Maybe it came to synchronize.